All right, so another application here of, in this case, the cross product is to find the area of a parallelogram. Now, if you think way back to grade 9, you probably did area of a parallelogram, and they told you that the area was base times height, okay, where they gave you some number that represented the length of the base, some number that represented the height of your parallelogram. In this case, rather than having your base be represented by some number that is giving you the size of the base, what we have are two vectors, which we'll call them vector u and vector v. These are vectors that are representing the two sides of our parallelogram here. And we want to figure out from these two vectors, these vectors are probably in Cartesian notation, what is the area of the parallelogram defined by these two vectors? Well, let's say we think about this in terms of this formula up here, base times height. Which of these two vectors represents our base here? Yeah, v, yeah. So our base here, we can just take the magnitude of that vector that represents our base. So the magnitude of v is the length of our base. The other thing we want is we want the height here. So how can we figure out the height from this information that we're given right here? Using the fact that there's like a little right angle triangle in here. Yeah, the y component, or if we want to find the y component of u, we take the magnitude of u, and what do we multiply by? We've got hypotenuse, we want to find opposite, yeah, we want sine. So the height here is represented by the magnitude of u times sine theta. So if we put this together, we get magnitude u, magnitude v, sine theta. Now, does this look familiar? Nodding head. Where have we seen this before? Not the dot product, but the... Yeah, this is the cross product. Okay? In fact, this was the magnitude of the cross product, u cross v. So if we've got vectors defining the two sides of our parallelogram, the area is just given by the magnitude of u cross v. Okay? Take the cross product of those two vectors, take the magnitude, and that gives you the area. And we take the magnitude because that ensures that we don't get a negative. Okay? And of course, when you do the cross product, you get a vector as an answer. So we want the magnitude of that vector that we get as our answer. Okay? And because we're doing the magnitude, it doesn't matter what order you do this in. V cross u, u cross v. We're taking the magnitude at the end, so it all sort of washes out. Okay? So let's take a look at an example here. Scroll down here. Give us ourselves a little bit more room. The points are 1, 1, 3, S, 3, negative 3, 6, and U, negative 2, 4, 7, are the three vertices of a parallelogram, RSTU. We want to find the area of RSTU. Now, I put a little note here, which suggests I'm supposed to remind you of something important. And I think the thing is, it's always a good idea to sketch your parallelogram here, RSTU, and when they label the points always get labeled in alphabetical order going around the outside of the parallelogram, either clockwise or counterclockwise. So in this case, they don't tell us where T is, but we know that if we go RS, T's got to come next and U has to come next. So we'll just say note, points are labeled clockwise or counterclockwise. or counterclockwise. Okay, so back to our question here. Find the area of RSTU. Well, based on what we did up above there, we know that our area is going to be the magnitude of the cross product of two vectors. So we have to choose two vectors that are going to define the two sides of our parallelogram here. And we have to choose our vectors in a specific way. They both have to start at a single point and go out in different directions like this. Okay? These two vectors have to be tail to tail when we choose them because, well, our vectors have always been tail to tail when we've chosen them. So in this case, what we want here is we want the cross product of RU and RS, because those are those two vectors that we've defined as our side and our base. So we need to figure out what these two vectors are. How can we figure out what vector RU is? That vector from R to U. We subtract R from U. So we want to do, I think we want to go the other way around. We want to do our ending point minus our starting point. So if we start at vector R, if we start at point R and we go to U, we want to do U minus V, or point U minus point V. So what we're going to have here is -2, 4, 7 minus our starting point is 1, 1, 3. Okay. So we do this subtraction component by component. -2 minus 1 gives us -3. 4 minus 1 gives us 3. 7 minus 3 gives us 4. So RU is the vector -3, 3, 4. And we want to do the same thing to find vector RS. Again, we're going to do our ending point minus our starting point. So our ending point here is S. So we want to do 3, -3, 6. And we're going to subtract our starting point, which was R, which is 1, 1, 3 again. And then we can figure out what RS is here. So 3 minus 1 is 2, -3 minus 1, -4, 6 minus 3 gives us 3. So we have the vector 2, -4, 3. And now we want to do the cross product here. So we want to do RU cross RS. Or we could do RS cross RU. It doesn't make much of a difference here because we're going to take the magnitude anyways. So let's set up our cross product here. We're going to do I, J, K. Give ourselves another copy of I over there. RU is -3, 3, 4. RS is 2, -4, 3. And then we want a -3, and we want a 2. So let's do our cross product. We want to start with our I component here, which means we want to go down on an angle there, and we get, let's see, 3 times 3, which is 9, minus -16, so that's going to give us 25. Okay. We want our J component, so we go again down on an angle. 4 times 2 gives us 8, and we're going to subtract -9, so that's adding 9, so we get 17. 8 and 9 is 17. And then our k component, we go, let's see, negative 3 times negative 4 is 12. 12 minus 6 is going to be 6. Okay. So 25, 17, 6. Did I do that right? I don't know about you guys. This is where I most often make the mistakes here, is doing this cross product. Either by adding numbers together instead of multiplying them, or subtracting these things incorrectly. So let's just double check here. 8, 9. Well, that looks okay. All right. So we've got our cross product here. Now what we want is we want the magnitude of that cross product. So we can just say that our area is going to be the magnitude of this vector 25, 17, 6, or the square root of 25 squared plus 17 squared plus 6 squared. And we can just sort of punch this into our calculator here. Okay, so let's see, 25, who's got a calculator that can punch this in for us? And what's that as a decimal? Okay. So either one is acceptable as your final answer there. Okay.